Okay, so in today's lesson, we're going to talk about radical and rational exponents. Okay, so specifically, we're going to talk about how to change radicals into rational exponents, and then we're going to talk about rational exponents and how to turn them into radicals. Okay, so writing expressions in radical form. So we're going to start with turning them into radicals. So when you have a rational exponent, so remember a rational number is any number written as a over b. So when you have a rational exponent in the form of a fraction, the numerator becomes the exponent and the denominator turns into the index. So what's going to happen is you're going to rewrite it like this. So you can see that the denominator of 3 becomes an index of 3, and then you raise that to the second power. And you can actually write it either way. So you can have the cubic root of 64 or the third root of 64 and all of that raised to the second power, or you can write it like this and you can have the cubic root of 64 squared. So let's look at how those differ when you simplify them. You do get the same answer. So either way you can see that the answer is 16, but watch what happens. On this first one, I take the cubic root of 64. So I can say that 4 times 4 times 4 is 64. So the cubic root of 64 is 4, and then I just have to square it, and I end up getting 16. However, if I did it this way, I first would be squaring 64. 64 times 64 is 4,096. And now you have to find out what can be multiplied together 3 times to give you 4,096, which is no easy task, especially given that you won't have a calculator to do these. So, therefore, it's much easier to do it this way and first take the cubic root than it is to use the exponent and then cube it. So let's look at some examples. So first, our first example here, example 1. If we have negative 8 to the 5th third, we know that the 3 becomes the index. You can see we write it right in here, so it's the third root, and then we write the negative 8 in here, and then we raise it to the 5th power. So we can see again it's much easier if we simplify what's in here first. So we know that negative 2 times negative 2 times negative 2 makes negative 8. So the third root of negative 8 is negative 2. And then we just raise that to the 5th power. So if we raise that to the 5th power, we will get negative 32. So that should be negative 32 there. Okay, on the second part, on the second example, we have 17 to the 3/4. So we have 17 to the 3/4. We take the 4 becomes the index, and the 3 becomes the exponent. So remember, we can write it either way. It could be inside or it could be outside. And on this one, that cannot be simplified. So there's no 4th root of 17 because 17 is a prime number. So it can't be simplified further. So you could give the answer as either of those. All right. Second. Next, what we're going to do is go the other way, writing expressions with rational exponents. So when we start with a radical, so it could look like this, the 6th root of 20 squared, or we could have the 6th root of 20 raised to the 2nd power. So you can see here that the index becomes the denominator, and the exponent becomes the numerator. And I just have to rewrite it. So I write the 20, and then the 2 is the numerator, and the 6 is the denominator, and of course, when possible, simplify. So I should change 2/6 into 1/3. So let's look at some further examples. Okay, so example 1. I have the 4th root of x to the 8th. So the index becomes the denominator, and the exponent becomes the numerator. And like I said, when possible, you should simplify. So it becomes x squared. On the second one, you have the 5th root of 13 to the 3rd power. So remember, it's the same way. It doesn't matter if it's under the radical or outside of here. Either way, the exponent becomes the numerator, and the index is the denominator. So my answer is 13 to the 3/5. So it's important to remember that the cubic root of x squared, when we put that under the radical, is the same thing as the cubic root of x raised to the 2nd power. So those are the exact same, and both simplify to the same thing. So if you turn them into rationals, both will give you x to the 2/3. All right, so remember this, it's very important, and that's it.